everyone. Okay, so I'm gonna do a quick tutorial on energy levels, and here we have the periodic table, which is well known everywhere. And as you can see the chemical symbols, you can see the atomic numbers on the top of the chemical symbol and the mass numbers, which is the big number at the bottom. And we know what these numbers means, and to remind you, the atomic number means the number of electrons the atom has, and also the number of protons the atom nucleus holds. And the number at the bottom, the big number, it tells you how many neutrons and the number of protons the atom's nucleus holds. So that's the small number at the top is the number of protons and also the number of electrons, and the big number is the number of protons plus the number of neutrons. So the bottom number tells you how much the nucleus of an atom weighs. Okay, and also you can see these numbers at the top, the periodic numbers and the group numbers. These are the numbers that's going to come in very handy when we have to work out the energy levels of an atom and when we have to draw them. Okay, so I'm going to get an example which is simple, carbon. We use that example a lot everywhere. So carbon, we have 4 at the top, which is the periodic table, 2 on the side as the group number. Okay, this is the important part. These numbers means a very important thing. The numbers at the top, the periodic numbers, means how many electrons can the atom hold on its outermost shell, which means the last shell. And the group number means how many electron shells the element has. So say for lithium, there's going to be 2 electron shells, and in that 2 electron shells, on the last shell, it's going to have 1 electron on its last shell, the outermost shell, which is also called a valence shell, but it's not important now. Okay, for the carbon, we have 4 and 2. So we know from the 2, the group number, it means it's going to be 2 electron shells. So we draw 2 electron shells for the carbon. And then we can see the top number says 4, which means it's going to have 4 on its outer shell, the last shell. It's going to have 4 electrons. So we draw 4 on the last shell. Okay, now this 6 comes in handy, the atomic number. So the 6 means how many electrons the atom has, which like I said before. So if the last shell has 4, the first one is going to definitely have 2 to add up and make 6 electrons. And this is the rule. As we know, the first electron shell can hold 2 electrons maximum, and the second shell can hold maximum up to 8. Third shell can hold 8, but we don't have a third one, but we have a second one and it holds 4. So there's the structure of the carbon atom, and we can write this as C, the chemical symbol, and then 2, which is what we have on the first shell, and then 4, what we have on the last shell. So if we go back, it proves the 4 at the top, which is the electron numbers on the last shell, 2, how many shells it has. So it's really easy. We can just work it out really quickly. So the next example, I'm going to do another one. Sodium. And if we look at the periodic table, sodium is right there on the first column, 3rd row. So let's go back to the symbol. We have sodium, Na. 11 is the electron number, and the proton number, but it's not important now. Electron number. 1, how many electrons it's going to have in the outer shell. 3, how many shells it's going to have. So because we see 3, we're going to draw 3 shells, and then we're going to move on to the last shell, and then we're going to draw 1 because it says 1 on the periodic number, and then we're going to fill the other ones up. If the last one, if we reach the last shell, that means the other ones has to be full. So if we add it all up, we're going to make 11, which is what we've been given as the electron number. And we can also write that as Na, 2 on the first shell, 8 on the second shell, 1 on the last shell. So it meets the criteria, it works. Okay, so the important notes we can take home from those is that this we know, this is the basic, the atomic number, the number of protons, also the number of electrons, and the mass number, number of protons plus the number of neutrons, which is important, which means that protons and neutrons are the ones in the nucleus of an atom. That means that's the mass of a nucleus. So that's the mass number, which is the big number. So that's the way to identify it. Atomic number, small one, mass number, big one. And you can't see it, you can't really fit it in anyway. Periodic number, I told you, the top one is the number of electrons the element holds in its valence shell. Valence means the last shell, which is another name. Anyway, is the outermost shell. And the group number, the number of electron shells the element holds. So the electrons, the group number, which is on the side, is the number of shells it's going to have. The periodic number, which is that way, so the rows, is the number of electrons it's going to have on its last shell.